All right, so we are going to start with ggplots2 package today. It's a good graphics package in R, and it must be downloaded as the same way as you installed a lot of other packages, install.packages, and you give it ggplots2. It will not come with the basic installation of R. You have to install it separately from R. So do this install of packages and then as usual load the ggplots2 package. So ggplots is a plotting software and a plotting package within R, and it works in a way of layers. So ggplots2 has certain commands where the first part of the command will build the first layer, and then you can add upon that those layers. And there are some defaults where it will work if you do not give any arguments, but essentially you will need to um, specify at least the basics like the x-axis, y-axis, and such. So basically there are many layers as you see here. The first layer, which is where you specify the data frame or the data set name, should be a data frame, and then you add upon it. Then you specify the x-axis and y-axis using an abbreviated function called AES, which stands for aesthetics, where you specify x equals which part or which column of the data set, and y equals which column of the data set in order to plot. So until now we have been plotting using the basic plotting methods in R, using the plot function, the hist, the bar, and the box plots, and others. But with ggplots is a more advanced way where you will get nicer plots, you will get some a grid-like structure on the back end, and you will have a lot more options and a lot easier options with ggplots2. So the next layer up after you add the data frame and the aesthetics, which is the x and the y-axis, you have um, you have to specify what type of plot you want. So basically, it's a geometric class object, and it's defined by the code word geom, geom, and you have a lot of options to this geom. You can either add bar, you can either add points or lines, and it will be clear in the next following slides. But this is just a gist and a quick look at what we are going to deal with today. And the next object that you deal with is after you specify what type of plot you want, the next type of object you deal with is how you want the statistical summary to happen in ggplots. If it's a summarizing for histogram, it's going to be in bins. Your data is going to be binned in terms of if you remember the mileage plot in empty cars, it's going to bin based on what mileage the car has. So it's like 5 to 35, and various others, different bins even in that, like maybe 5 to 10, 10 to 15, and 25 to 35, something like that. So it's going to bin, and for a continuous data, you can specify the statistical keyword for smoothing the drawing, and you can also add a regression lines to it. So we'll look at it more in detail in the following few slides. So this is the first example, and we are using the data set called Faithful. So Faithful is an existing data set which ships with R. So it is already built in your R. It's already loaded. It's already built in your R installation. It's the data from your Faithful geyser. It's it's in Yellowstone, I think Yellowstone National Park in Utah. So this is a very active geyser. So basically, it spills water every some a few minutes, maybe 10 minutes, every 10 minutes. So it spills hot water from the earth, and so they have recorded data from this geyser. So basically, you have the two columns. One is called eruptions and the other is called weighting. So basically, eruptions both are in terms of minutes, I suppose. In terms of minutes, so eruption is how long the geyser keeps flowing the water, and weighting is the wait time until the next geyser eruption. So this is the type of data that we are plotting. And so just a bit of introduction to these plots. So sometimes you may wonder what type of plot is and visualization is actually needed in order to show certain data, and to always all the time the same type of plot or a scatter plot may not be the right option. There are many options like this. You have seen the scatter plot, but there are many options, scatter plots. You have line plots, line and scatter plots. You have bar plots, you have box plots. Um, so basically, it depends on what type of visualization is best to represent that data. So in this case, since we have times, waiting times, and eruption times, and it may be useful for us to see the pattern of it, and and so we are using a scatter plot or in this example. So with ggplot, what you do is you first use the keyword ggplot, and faithful is our data set. Faithful, you give it the first argument is going to be the data set, and then you specify the aesthetics, the x-axis and y-axis. So within, you have to use the AES keyword, and then you use x, and so we want the x as the eruptions here, and y is the wait time. So in ggplot, since if you remember, the plotting is in terms of layering. So you add the first layer, you're specifying the data set, you have the x-axis and y-axis, and then you build upon this. So you build upon this. Whenever you want to build upon an existing layer, you use this plus symbol. So use the plus symbol. It's not two pluses. Since I've copy pasted this one from the console, it's actually showing this plus symbol, but there's only one plus. So you add the plus, and then you specify what type of plot you want. So the keyword for this type of plots is, since we want a scatter or the dot or a scatter plot, it's we have to specify geom underscore point, and then leave it as empty. So I'll tell you what other parameters you can use within this brackets, but for now, let's leave it at the defaults. And then we add another layer upon this point, and we call it stat underscore smooth. So I'll tell you what the meaning of this is, but this is our first plot. So the first layer is, it will set the panel, and it will set the x and y axis, this first line, and then you add the points to it, then you add the scatter plot, all the points to it, and then the third layer is you add the statistics to it, which is a smoothing curve. So basically, it's the same thing. The slide is the same thing that I've just told you. The first layer is the data and mapping, and then you use, then you specify the aesthetics. Then you have the types of plots and the stats. So let's just do it practically here instead of just talking about it. So you'll have to first load your package, which is your ggplots. And here I'm just going to look at the faithful data sets. It just has two columns. One is the eruptions and the other is the weighting. So both of these are times, and the eruptions usually happen in terms of like minutes, maybe 3 minutes or 3.6 minutes, 5 minutes, and so on. And then the waiting time until the next eruption. So this is also in minutes. So there's 79 minutes before the next eruption happened. So this very first line, it sets the stage. So if you just do this one without adding the point or smooth, it's just going to display this empty panel with X and Y axis set up. And then if you want to add this, so you'll have to run the whole thing. So now you see that the panel is set, the X and Y axis are set, and the points are set. And now you can add a smoothing function. So this is a regression line and a smoothing function. So what is meaning of smoothing function is it adds the confidence interval on the 95% confidence interval on either side of your line. So that's the plot. Let's go back to our All right, so these are the various types of plots that you can specify within your geom. So if you want a bar chart, then it's geom underscore bar. And if you don't specify, if you just give it geom underscore bar, and if you leave it there, there is a default statistical summarization method associated with each of these plotting styles. So if you want a bar chart and leave it at this without specifying the stat underscore, then it's going to take the default as stat underscore bin. So stat underscore bin is the default, and it will do the default binning mechanism. It's the same as the bar plots or the histogram that you do in your normal plotting mechanism. If you don't specify the number of bins, it's going to do it on its own. So let's try to do it over here. I don't have it here, but let's try to turn this into a bar and see if that works. Okay, so bar doesn't need a Y. It's only going to be an X, so that's wrong. And if you remember, the bars are basically frequency. It's going to take the frequency. So right now, you don't have to specify a Y for your bar plots, since you see that these are the number of eruptions, and it's going to give the distribution in terms of how many are at between 1 and 2 minutes of eruptions, and that's like 4 eruptions are happening here, 2 eruptions are happening, and then within 4.5 to 5 minutes there are that's the highest, about 5 eruptions happening at that time. So this is basically, let's see how many data set or how many plots, how many lines of data we have. We have about 272 lines, so this is only data with 272 data points. It's a small data set, but your usual data sets are much larger than this, and hence the distribution of this plot does not convey much. But if you have a larger data set, say about 1,000 points, then you might want to look at the distribution and see, where are the maximum number of data points falling in which bin, and so on. So this bar plot was more helpful for, or the histogram was more helpful for your empty cars data set, where you wanted to see where the largest number of cars fall in, which bin of your mileage. So here this doesn't inform us much, but I'm just showing you to demonstrate the bar part of this. So geom underscore point is the one that we just saw. It's just a dot plot or a scatter plot. And its basic default mechanism is stat underscore identity. So identity is nothing but it's going to take the points, it's going to draw the values at the face value, meaning it's just going to take the point and put a dot wherever the x and y, whatever the x and y values are. So identity is use the values as it is. Do not bin them, do not, smooth or anything. So the next one is geom underscore line. This is for a dot and the line plots. If you have some time series data and you want to see where it's going or how the pattern is according to time, then you use a geom underscore line. This is a dot and a line plot. And the default for this also is stat underscore identity, which is use the points at the face value. So the next is a box plot, box and whiskers plot. This is again used for binning the data, looking at differences between two groups of data that you want to test. You can use the box plot, geom underscore box plot, and the default is box plot. It doesn't really, it's basically like a stat identity. Just use it as it is and draw group it as it is. So path again is where you connect the observations. It is like a line and a dot and a line, but it's going to reorder your points and draw lines in the order that you give it. Geom underscore smooth is a smoothing plot. It's like the one we just saw, the previous one. So like this plot, this is the smoothing function. So if you don't specify the point and you just give geom underscore smooth, it's just going to draw that line, but you need the y2. So let's give the y. So it's just going to draw that line, smoothing line. And geom underscore histogram is similar to bar plot. So it's just an alias for bar. So your bars and histograms are one and the same. It's just an alias for underscore bar. So the default again is underscore bin, stat underscore bin. So it's going to choose its own bin. It's going to bin the data according to its own internal analysis of what the data looks like and how many bins it needs, unless you specify and want it in different formats. All right, so now we are going to use a data set called as quakes. So let's see what this data set actually means. I think it's earthquakes in some area. So let's look at the help. Oh yeah, so it's right here. So it's basically location of the earthquakes off Fiji. It's like a New Zealand, is that right? Yeah, it's off of it's a trench off of New Zealand, and you observe a lot of quakes in that area in terms of the plains. So they have recorded data from that trench. And what type of data they have is they have the latitude, longitude, and depth at which the quakes are occurring, the richer magnitude, the magnitude of the quake, and the number of stations reporting the quake. So 1,000 observations, 5 variables, you have this data inbuilt within this, within R. So let's use that to see the use of ggplots. So we are using Quakes data set, and we are trying to make a histogram or a bar plot, and therefore we need just the x. So x, we use it as depth, which is at the depth of the quake, occurrence of the quake, and we should add the plotting layer, which is the type of the plot. the geom underscore histogram. And so it's going to use, so it's, since we have not specified the statistics or the binning strategy, they have picked one. The R has picked one for us, so it's giving you as the stat underscore bin is using bins equals 30. So if you don't like that, then you have to specify your own bin. You can do it in stat underscore bin, or you can specify another parameter within geom underscore histogram. It's called bin width, and you give it a number, and so that's going to pick the number of bins, or so basically draw how long or how thick your bar is going to be. So since we have picked 50 over here, it means that we are trying to bin it every 50 meters or whatever the unit is. Maybe it's 50 meters or kilometers. So we are binning it every 50 kilometers. All right, so you see this, it's kind of prettier than your normal bar plot, and sometimes it's necessary to have these grid lines on the back side, like behind the plot, because it's so for bars that are further away from the axes, it's easier to see if you have a grid line at the back, just to see what level they are at. So here I can clearly see that, okay, the count is around like 125. As opposed to if you had nothing on the background, then you will have to kind of guess where it is. So yeah, so you can try this on your own. I'm not going to demonstrate every single thing. And I'll share the slides with you so you can try this on your own. So the next is, again, using the quakes. So this data set demonstrates the use of these various types of plotting, because over here, the very first plot, we are using a histogram because we wanted to see like what, the largest number of quakes, at what depth do they occur? The largest number of quakes. So usually from this, what do you find out? You see a peak, and you see a peak. Where is that peak? Over here. So you see that peak. You see that there is, out of the 1,000 data points that we have in the data set, about almost close to 200 of them occur at the first 50, within the first 50, is it 50? Yeah, the first 50 to 75 kind of. So this is 100, right? So this is 100 and this is 50 is somewhere over here. So between the first 50 to 75 kilometers, the most of your quakes occur. So this just gives an idea of how your data set is distributed, and we see the maximum peak over there, and maybe another peak over here, which is at 500, between 500 to 600 kilometers. So you see that. And this type of plot, a dot plot, is needed where you want to locate the exact longitude and latitude of the space or the spot the quake is occurring. So this type of data, if you have longitude and latitude, it doesn't really make sense to draw a histogram or a bar plot, because it wouldn't tell you much. Maybe it's telling you like how many quakes, or the largest number of quakes happening at a particular latitude and longitude, but it's two plots, as opposed to if you draw just a point or a plot where you can a point plot or a scatter plot where you can locate the exact location of these quakes. So this is, on the x-axis you have latitude and longitude, and you can pinpoint exactly where the quakes are occurring. So we are using a geom underscore point, which is just a scatter plot, and you have all the points at wherever the data is. So you see that between longitude 180 and 185 and latitudes this 15 and 25, you have the most number of plots or points or the quakes. So, and there is nothing much on this side, so you can determine, the safe areas and the less likely quake areas. So the line, the dot and line plots are, again, if you want to see the trend or if you have a series of data. So this is another data set where we use, it's called Longley, and it's an unemployment. I think one of the previous sessions we used this data set. It is an unemployment records. It basically gives the year and the percent or the number of unemployed people. I think it's in the US. You can look at the description of the data set on your own using the help. And so if you want to see or see the trend over time and how it's changing, then it's you just have to use the time scale as the x-axis. So this is, in this data set, it's the year, but if so one other example that we can use, this line series plot is maybe heart rate or something like that, like the time series data, heart rate or brain pulses. So it varies and depends on the time and what time of the day and things like that. So you can have a time series plot, and here we have a year as the x-axis, and we are plotting the number of unemployment on the y-axis, and we see this trend that it's going up and down. Between 50 and 55 was low unemployment, and then it rises at the end of 55, and then more than this, here is the highest unemployment around the 60s. So just to look at the trend of the data set. And here are more options for the stats part of the layer. So any questions until now? I have not stopped in middle, but any questions until now? Okay. So the fourth argument, which is the stats, again, as I told you, there are the default stats part for the type of plotting you use. So there are default stats, but if you have to specify the stats, then so if you don't specify the plots and you just give it the stat, it's going to plot the default plotting variable. So both of them complement each other. So if you specify just the plot type of plots, the stats, the default stats get picked up. If you just specify the stats, the default plot gets picked up. So both go hand in hand, and so for ggplot, the very important part is this first part, where you have to specify the data set, you have to specify the aesthetics, x and y, and just x depending on what type of plot you want. And then you can specify one of the two, which is the type of the plot or the stats that you want. So so we have gone through stat bin, we have gone through smooth. So sum, stat sum, it actually adds up the values. So stat sum, again, its default is geom_point. So it adds up these values, and stat identity is it doesn't do anything. So there is basically no summary of these plots. It just uses the points as it is. And that's, again, the default is geom_point, which is the scatter plot. And there is a box plot, and the box plots stats are always summarized according to the various groups in the boxes. All right. So until now, we just looked at the type of the plots and the stats. we'll just talk a little bit about the regression lines. So using the same data, Longley data, for the years and the number of unemployed or employed here. Here we are talking about employed, and I think it's percentage. So yeah, so it's a percentage, and we are plotting basically the trend of employed in these particular years, and there looks like a clear increasing employed percentage comparing all these years. So in order to, if you remember the modeling class that we did, we can model the data in various ways, and one of the simplest is the linear regression model. So when we have a plot like this, people want to see what does the model look like, and we can do that two ways. You can use the AB line, or you can use the stat underscore smooth. So stat underscore smooth, it has a default. By default, it uses a method called lowest. I think it's lowest. So it's and if you want a linear regression model, you'll have to specify it here. So one other thing that I forgot to tell you over here is what you can do is you can specify the basic ggplot parameters over here. You can even skip this geom part. You can basically specify just this ggplot and assign it to a variable. You can assign it to a variable and then use this variable to add on the various other layers. So that's easier way. We usually use that because if we want to use this basic layer, to create a lot of other different plots from the base on the basic layer, then we assign it to a variable and then use this p variable. So here that's what I'm doing, using this p and then adding on the other layer, which is stat underscore smooth. So in order to do the linear regression model, you'll have to specify the methods here. So you'll have to specify the method as LM, which stands for linear model. And now you see that there are no longer those curvy lines. It's a linear model, so it's a straight line equation and the confidence interval around it. So you can add something called facets. So facets, to understand facets, it's easier to go back to our MTCars data set. So in this data set, again, you can use the same modeling for MPG versus horsepower. So you specify the Y as the MPG and X as the horsepower. So you have ggplots, MTCars, aesthetic, specify X equals, Y equals, and then points. So if you do this, you will have a plot like this where it's treating the values as a face value. So you see that this was a trend that we observed, that the highest mileage occurs if it's low horsepower. And as the horsepower increases, the mileage kind of reduces. So you have this line, which is a decreasing relationship between mileage and horsepower. So in order to demonstrate the facets of this, you can basically divide this data into various, you can add another dimension to these plots. So we have the horsepower and MPG. If you want to divide this and look at the number of cylinders and see how the MPG and horsepower change within each type of cylinders, we add this different facet, which is a facet grid, and we give it the value cylinders with this tilde. So basically, we are taking whatever is existing. As I told you previously, you can assign this to a variable, use that variable. So we are using this variable, adding two more layers to it. One is the stat underscore smooth. We want to see the linear relationship in this model, and linear regression modeling, and then add another layer to it, which is the facet grid, and divide this data into categories as the cylinder. So cylinder is a factor variable. It has three values, which is 4, 6, and 8 cylinders. And now we have the data broken down accordingly into these facets. This is quite important because most times none of our data analysis will be as simple as, just plot. These are the X and Y and just plot it. So this is something that we use more often, where we'll have to probably divide the data depending on the various facets. So here, if you see the 4, 6, and 8, and MP, MPG, and HP are, MPG is going to be the common one, the common axis to all the three. The y-axis is going to be common, and the x-axis will be repeated in the three facets of the grid. So again, you can color these. There are various parameters even within the single, the plotting or the layering, and so you can color it and name it accordingly. So most times people want to see this. If you want to you don't want the facets. You want to put it in one plot, but you want to just color it differently. So within the aesthetics, within the points, the geom point layer, you can add another variable, which is again starts with ACE, which stands for aesthetics, and you can add two other parameters, which is the shape and the color. So you want to differentiate these three layers, or whatever you want to differentiate, with a shape, with a different shape and a different color. So you're giving shape variable and giving it the factor of cylinders, which is three factors, 4, 6, and 8, and you're also wanting a different color for it. So you give it shape and color, and then these are colored differently. So you see that 4 cylinder cars are colored differently, 6 and 8. So this is a much better plot. So it depends on what situation you're in and what type of output is needed, and accordingly you might use this facet grid, or this type of plot, use one plot and differentiate the points. So this is another way of doing it, and this is, you could either do it with this way, color coding it, or you can use this another layer, which is called scale shape discrete, and you give it by which you want to differentiate it. So this is another way of doing it. It depends on what you want to use, and mostly if you already have a variable which says ggplot, empty cars, and this one, and if you have just geom underscore point, you don't have any more variables within the geom underscore point, and then you assign it to a variable, then you can use the p and add this one upon it, scale underscore shape underscore discrete, to differentiate it. So ggplots has this advantage of changing the plots and the type of plots at various layers. So these are the various layers, and you can change the type of plots. So if you have to do this in your normal R coding, you'll have to write several lines of plots. You'll have to add these points, even to change the color, differentiate the colors between these data points. You'll have to write maybe 3 lines of code for defining the points by text and lines, and various other parameters you can use for in your normal way of R coding. But ggplots makes it simpler by making your dividing your plots into layers, and you can add each layer upon layer to make your final plot look like the way you want. So there are other resources for ggplots. You can use this website, which is the ggplots2 website. It has all examples for, all the most of the examples that I've picked here. It has lots of other examples for, if you want to go deeper into, I touched upon geom, stats, and facets, but if you want to go deeper, then you have like scales and other layers that you can add on to ggplots. And there is another website, ggplots.org.book, where this author of ggplots 2 package, he has written a book. So that's another resource, good resource to dig deeper into ggplots. And there is also a wiki page you can use to dive deeper into ggplots. So mostly people are using this ggplots for plotting these days. Unless like you're a beginner R coder, you will do those inbuilt R program plots, but mostly it's ggplots too nowadays. So that's about it I have for today. Um, any questions?